That's it. It's just a little bit. So we can why did the arch over here?
How high did it go? How high? Like, I should prep on the first thing. I haven't done like real math since I was like.
Just that they would not do it.
Yeah, I mean, I think it's
So that they would drop
whenever the like it's always for like
to be similar.
yeah.
It's a parabola problem. I'm staying. The only right one I think is by people calling staying. Yeah. She's something. But she's going to year or so.
But shouldn't have to be, I think.
Yeah, he is. They went to see him. Summer she started.
I ended up doing like, had my car accident, like, replacing my yeah, so that's so my experience of like how I prepared for public instead of doing like I do like that's something in the hospital. I was, yes. Probably not. But I did. Yeah, I don't know. And I like the GRE grad school like
I know. And then same thing. And then when I was tutoring for math now, oh, that's what that was for. Because I can tutor my daughter, and she can tutor her daughter.
Yeah.
That would really nice.
Because I knew I could study if I left it myself on my own, but like
I know.
Oh, really?
Yeah.
Lots of seats on both sides, so feel free. So let me get us started.
Yeah.
Although I'm sure we'll see more people come in as the clock keeps ticking. Welcome to the first of our seminars on ethical, legal, and social implications of genetics in 2015. This series continues on a monthly basis through June, and then we take a break for the summer. We'll start up again in September, and just by way of coming attractions, next month on February 11th, Candice Hodgers from the Departments of Psychology and Neuroscience from Duke will be up here to speak to us about some of the work they're doing related to epigenetics, and we will be getting out an announcement very shortly about that, and you can put that on your calendar. Today, however, I'm delighted to be able to introduce to you Jim Tabery. Jim is an associate professor of philosophy at the University of Utah. He also has an adjunct appointments there in medicine and pediatrics. His background is in the history and philosophy of science. He trained at the University of Pittsburgh, which is maybe the leading department in history and philosophy of science in the country. And for those of you who would like to pursue some very interesting thoughts about the interaction between genetics and environment, I commend in the strongest terms to you Jim's book, which is called Beyond Versus, the struggle to understand the interaction of nature and nurture. MIT Press, terrific read and a very interesting historical overview of the ways in which we've struggled to understand how genetic influences and environmental influences combine to effect changes in our behavior. Today, Jim is going to be speaking to us about dogs, daycare, and discipline, a genetic guide to parenting. So,
question
Jim,
mark.
Question mark. A genetic guide to parenting. And Jim, thank you so much for joining us.
Thanks, Paul. It's a delight to be here. I thought I'd start just by way of a little bit of sort of background information to tell you how I came to the particular topic I'll be talking about today. Towards the end of the book that Paul just mentioned, I wanted to get into some of the ethical issues, the ELSI issues, the bioethic issues that I saw raised by research on gene-environment interaction. And if you are into that world, ethics issues, ELSI issues that are raised by research on gene-environment interaction, one of the things you'll quickly realize is that literature is dominated by one paper in particular. And it's this paper by Terry Moffat and Avshalom Caspi, that's the two on the right there, Role of Genotypes in the Cycle of Violence in Maltreated Children. They published this in Science back in 2002. It received a lot of attention. For those of you that aren't familiar with it, I suspect many of you are, but basically what they found was they looked at a particular genetic variable, high versus low MAOA activity, exposure to varying levels of childhood maltreatment, and then what they were looking at the phenotypic level was antisocial behaviors, which unfortunately correlate quite high with things like violence and criminal violence. And so because they were looking at a genetic variable, an environmental variable, they were looking at a very controversial trait, criminality and violence, it got a lot of attention. And kind of in short, what they found was if you had the low version of MAOA and you were exposed to severe childhood maltreatment, you were at a much higher risk of going on to develop antisocial personality disorder than if you had the high variant. I think it's a fascinating study. So what I should start by saying is I don't start off here as a knock against them. I think it's a fascinating study. I think the bioethics literature that's been written about it is really interesting. But I think it's sort of time to get out of the shadow of that one paper. And so the reason I'm trying to kind of move out of the shadow of that one paper is two reasons. One is there are many, many, many studies of gene-environment interaction. This is but one. And so to think that kind of the bioethics issues only come out of a particular study, namely the studies of violence and a particular environmental variable and genetic variable, I think kind of misses the wider issues that we're likely to encounter if we kind of expand our view to incorporate some of these other studies. And then the second reason is because it's ironically, when you look at this kind of the range of studies that are out there, it's ironically, if you're interested in intervening in the world to do something about a trait that you don't want to see, it's interestingly a rather uncontroversial study in that, so when the study came out, people were making claims like maybe we should be screening embryos for whether or not they have the low activity variant so that we can kind of select embryos that won't have this disposition to violence. Maybe we should be screening all newborns to find out who has the low activity variant so that we can kind of keep an eye on these folks. And people have actually made the case for doing that. The easy solution is just to not maltreat the children. I mean, literally, if you don't maltreat the children, the genetic difference has no effect at all. Okay, and so it's in that case which I think it's a rather easy study because it's not like people are out there advocating for childhood maltreatment. If you can kind of get rid of childhood maltreatment, the ethical issues sort of evaporate. Now you could have a discussion about how feasible that is, and in a world where we can't get rid of childhood maltreatment, maybe we should be thinking about genetics. But just to kind of put all that aside, if you're just sort of interested in controversy surrounding intervening in the world in light of this information, this one's kind of interestingly non-controversial because the environmental variable is just so obviously bad. Okay. So that's one of the things that brought me to this study. The thought was, other cases that we can think about. The other thing that happened about 9 months ago, my wife gave birth to our beautiful daughter Olivia, and so this was the first time. Something I was thinking about things that I was never thinking about before. Things like, how are we going to pay for daycare, right? And who's going to, where are we going to send her? How are we going to discipline our child when she misbehaves, right? It became clear that my wife and I were exposed to very different parenting styles, and so when you kind of then have to start thinking about what kind of parenting style you're going to deploy with your child, there's this kind of negotiation and thinking through about how you're going to do that. And so I realized that I was asking questions and thinking about things that I was never thinking about before, and I think that's the other thing that sort of influences where this comes from. So what you're going to see me talking about is cases of gene-environment interaction, nothing to do with MAOA and childhood maltreatment, where the environmental variable are things that parents make decisions about all the time. And so what I'm sort of interested in is the possibility of genetic information about a child influencing these decisions that parents have been making for centuries, millennia, and what that would look like. So here's how I'm going to proceed through it. I'm going to start by just talking about a couple cases. In part 2, I'll look at what's the possibility that the sort of genetic information that I'll be talking about in part 1 could conceivably figure into medical decision making about children. And then in part 3, I'll be asking, sort of put my bioethics hat on, what would this look like if it happened? What would be the costs and benefits associated with having this sort of information available and implemented by people interested in affecting the outcomes of their children? So let me start with part 1. I've been talking about gene-environment interaction so far, but a very quick primer for those of you that aren't familiar with it. Cases of gene-environment interaction refer to cases, or the concept of gene-environment interaction refers to cases where individuals with different genetic variants respond differently to an environmental array. Okay? And so what you're looking at here are something called norm of reaction graphs. And the way norm of reaction graphs work are across the x-axis, you have some environmental difference that you're interested in looking at. So let's just focus on the one on the left. What they're looking at is either being raised in a home or being born into a home that has a dog there, okay? Or being born and raised in a home in the first couple years of life where there is no dog. On the y-axis, they're going to look at some trait they're interested in. In this case, they were looking at various types of allergies. Here it was eczema, and so the kind of proportion of the percentage of kids in the study who had eczema or didn't. And then the lines represent different genotypic curves. So what you're looking at is, right, the red line is the children in the study who were heterozygous at that particular gene, what their eczema percentage was in the no dog ownership condition versus the dog ownership condition. The blue line is for the homozygous for cytosine, and the green is the homozygous for the T. Same thing on the right-hand side, looking at the same gene. Now they're looking at exposure to daycare in the first 2 years of life across the x-axis, and also looking at allergies, but now they're looking at allergies to specific things in the air like mite and cedar pollen. Okay. So these are both studies of gene-environment interaction. They're both looking at something called the CD14 gene. So the CD14 gene is a gene that makes the CD14 molecule, and it's a molecule that affects basically how our immune system responds to perceived invaders. So it's a gene that creates a molecule. The molecule kind of, when we get something on our skin or something in our body, it's detecting whether or not that's the sort of thing we should be throwing an immune response at or not. The study on the left, it was by a team between Michigan and Wisconsin. They were looking at basically a sample of people in the area that already had a family history of various allergies and asthmas, and then looked at the children of those families, okay, for a variety of different environmental exposures, and then looked at particular genes as well. And so what you can see what they got here is a sort of classic case of gene-environment interaction. For the children that had the CC variant of CD14, being raised in a home with or without a dog had virtually no effect on the rate of eczema in that population. But if you were the TT variant or the CT variant, being raised in a home with a dog actually significantly reduced your risk of developing eczema. So just to focus on the children with the TT variant, that's the green line. If they were raised in a home with a dog, over 40% of them went on to develop some form of allergic eczema. If they were raised in a home with a dog, that number went down to 5%. So a real drastic drop. The study on the right, again looking at the CD14 gene, this is from a team out of Japan. And what they were looking at was, again, kind of allergies to things in the air like mite or cedar pollen. They're looking at exposure or lack of exposure to daycare. The blue line that goes up is not significant, but you can see for the kids that had either the CT or the TT variant, being sent to daycare significantly reduced their risk of developing allergies to these various things in the air. No obvious effect, no statistical effect on those who were, had the CC variant. These are kind of cases of gene-environment interaction. That's a medical trait. Let me look at one more, and this is a behavioral trait. There's a team at the University of Netherlands that have been looking at how nature and nurture interact with regards to externalizing behavior in children. So externalizing behavior in children are basically, it's the opposite of internalizing behavior. It's when kids get worked up, they lash out. Tantrums, violent outbursts, defiant behavior. That's the sort of thing that's all lumped together as externalizing behavior. And it's scored, the kind of tool they use to score externalizing behavior is something called the Childhood Behavior Checklist. And so what you're seeing on the y-axis there is basically higher or lower scores for children on a child behavior checklist. Higher being kind of showing more signs of externalizing behavior, lower being showing less. The environmental variable they were interested in is different approaches to parenting, and in particular different approaches to parental sensitivity. So a child throws some kind of a temper tantrum. A high sensitivity parent would do things like try to distract the child from whatever it is that's getting them frustrated. Empathize with the child. I can see why this is getting you upset. That really makes me feel bad. Let's try to do something else, right? So you're kind of sort of trying to relate to the child, get on their level, tell them you feel really bad about it, distract them from whatever it is that's getting them worked up. A low sensitivity parent, in contrast, as they understand or define it, is going to use more of an authoritarian, punitive approach to punishing. You're throwing a temper tantrum. If you do this, you're going to have to go to your room, right? You're at risk of getting punished. So it's much more sort of, I'm not empathizing with you, I'm not trying to distract you, you're stepping out of lines, there are consequences associated with that. The genetic variable they looked at was the DRD4 gene. The DRD4 gene is a gene that is involved in dopamine neurotransmission in the brain, and it comes in a high and a low form. So the red line is reflecting the high or the long form of the DRD4 gene. The blue line is reflecting the short form of the DRD4 gene. And what you can see is for kids that had the short version of the gene, that's the blue line there, being exposed to low or high sensitivity parenting didn't have much of an effect at all. The line goes up a little bit when you move from low to or from high sensitivity to, or if you move from low sensitivity to high sensitivity, but that's not statistically significant. But for the kids who have the long version of the gene, there's this really drastic drop in terms of their CBC score on if they're exposed to low sensitivity, or sorry, high sensitivity parenting. If they're exposed to high sensitivity parenting, it's a real drastic drop. What's interesting about this group is they started with just an observational study. So they started just by looking at finding parents that engaged in different parenting styles, categorized them as such, sequenced the children's genomes, find out which version of DRD4, and then found this result. Well, what they've done since then is a series of experimental studies. So what they're doing now is kind of sending people into the homes to teach parents how to engage in high sensitivity parenting. And then seeing how the kids with the different genetic variants respond to that intervention. And what's interesting is they get a pretty similar pattern here. For the children with the long version of the DRD4 gene, when this intervention takes place and the parents learn how to engage in high sensitivity parenting, compared to the control group, there's quite a drop in externalizing behavior. For the kids who have the short version of the gene, it's the opposite case. It's similar to what we see here. It's not statistically significant, but it goes up ever so slightly. And so you see this pattern in 3 or 4 studies that they've done now, where for the long version there's a real obvious drop, and for the short version there's a non-significant increase. So these are cases of gene-environment interaction. Before I move on, I wanted to just sort of say a real quick note about the studies that I've been talking about. So all of the cases, all the examples that I've been talking about so far are examples of what are called candidate gene-environment interactions. And so that little c, G cross E is the common way of abbreviating it. Caspian-Moffitt stuff about a decade ago, the studies I've been talking about since then, those are all examples of candidate gene-environment interaction. Throughout, I'd say, the first decade of the 21st century, people were really, really excited about this work. The thought was, this is kind of pushed through the failures to replicate earlier gene behavior associations, and by combining genes that we thought were promising but didn't replicate with environmental variables that we know affect the conditions we're interested in, we're going to account for much more of the variation in the behavior that we're trying to understand than if we just look at genes by themselves. And Caspian-Moffitt kind of, basically made a career out of doing a series of these studies and people getting real excited about them. We mentioned the one on antisocial behavior, but they also had one on IQ, they had one on depression, they had one on schizophrenia. Here's the thing, though. In the last 5 years or so, people have become increasingly skeptical of this candidate gene research in general, and then the candidate gene environment interaction research as an instance of that more general candidate gene research. When the initial studies were reported, the natural thing to do, people went out and tried to replicate them. But rather than all coming back, so just to pick one of their other studies, the Caspian-Moffitt study on depression, was replicated or attempted to be replicated dozens upon dozens of times in the first 5 or 6 years of when it was first reported. You would hope, right, those replications would all either come back and say, yes, we're finding the same thing, or no, we don't find it. In fact, what they got was a sort of mixed bag. A lot of the studies came back and said, we found the same interaction result you did. Many of them came back and said, we didn't find the same interaction result you did. Some of them came back and said, we found the exact opposite you did. The gene that you said decreases chance of depression, we found it's the other way around. So when faced with that, teams of scientists did the natural thing. They said, well, let's do a meta-analysis. What we should do is kind of pool all those replications together and then figure out whether or not, when you look at that huge data set, whether you find the interaction result there or not. Here's the problem. 3 meta-analyses have been done to date. That's the front pages of each of them. 2 didn't find the original result. 1 did. So now scientists are sort of kind of at this, what's going on here? There is no meta-analysis. There's no higher authority you appeal to when meta-analyses disagree. And so, I mean, I've got I can talk more about this episode. There's a chapter in the book about it. But all I wanted to kind of get to you on the table at this point is, there's some real concerns about this candidate gene research. The thought is it's not replicating the way we would hope results would replicate if we think they're reliable. And the explanation that's been given for why they were so popular or fun is that there's been a publication bias. Basically, people wanted to see these interesting interaction results, and so when they got them, novel interactions were published very, very quickly, but they were just chance findings, right? So it's not charges of fabrication or falsification, but the thought is it's just chance findings people got excited about, and right now the literature is littered with chance findings. And so a number of people have come forward and basically made that publication bias argument. The Behavior Genetics, the journal that often kind of is interested in this research, just a year or 2 ago published an editorial where they basically said, like, we are establishing new rules for allowing candidate gene and candidate gene by environment research into our journals because we don't trust it on itself. And so there's kind of various boxes you have to check if you want to submit a manuscript that's about a candidate gene or a candidate gene environment interaction. Take all this stuff with a grain of salt. There's a lot of people out there in the human genetics world who think this candidate gene stuff is bumpkiss. Many of those people aren't just saying that's garbage. They're saying it's garbage, and here's what you should be doing. What you should be doing are genome-wide association studies. That's the GWA. You sometimes will hear GWA acronym or GWA phrase used. The way a GWA works is, rather than trying to kind of take a candidate gene and see if it is mediated by an environmental effect, you look at the entire genome of people. So you take 2 huge samples. We're talking potentially hundreds of thousands, hundreds of thousands of people here. You look for some trait that you're interested in, schizophrenia, IQ. Look at portions of the genome spread out across all of their genomes and see if individuals with the thing you're interested in have certain markers that individuals who don't have them lack. Okay, and so GWAS studies are now getting reported quite frequently. There was a big study on IQ published just last year. The problem with these GWAS studies are they are finding SNPs, they're finding locations on the genome that looks like they're associated with the difference that people are interested in, but it's a very, very small portion of the variation. So IQ, they kind of screened over 100,000 people to look for locations on the genome that would be associated with differences in IQ. They found 3 promising genes, and those genes accounted for 2 IQ points in terms of the difference that they were studying, right? So the critics of the candidate gene work are often pointing to GWAS as the alternative, but it's important to say here, the GWAS stuff is also sort of, it's controversial, and not everybody's on that boat either. All I need to say is I'm kind of stepping into this next part of the talk. Whether you're in the candidate gene-environment interaction camp or the GWA camp, the stuff that I'm saying moving forward is equally relevant. Okay? So what I'm going to be looking at in the next section is, what if parents and doctors got the whole genome sequence of their children, and then were interested in making decisions about things like whether or not to send a child to daycare, whether or not to get a dog or a cat, in light of that genetic information? A candidate gene-environment interaction works very cleanly. It's like, oh, we look at what I just showed you. Which DRD4 variant do they have? Is that going to affect the way we're going to parent? The way a GWA would work is it wouldn't be 1 gene, maybe it's 3 genes. And then what you would do is do a sort of 3-gene by-environment interaction and see whether or not those 3 genes affect response to the environment one way or the other. Now, the other possibility is you just think the genetics of complex traits is bad, and it's not going to tell us anything. If you think the genetics of complex traits isn't going to tell us anything, then you can tune out from here on, right? So part of what I'm sort of saying here is, if the world looks like the sort of results we're getting from the people who do the candidate gene-environment interaction research, or the world looks like the sort of results we're getting from people who are excited about GWA, and then GWA by environment interaction, then here's the sort of bioethical issues that I think we should sort of worry about. But I want to just say, I think it's an entirely rational position to hold, to be, and say, I don't think we're ever going to get any operational information out of these whole genomes, right? We got the low-hanging fruit with Mendelian traits, and that's all there's really going to be. And whether you're interested in schizophrenia or IQ or even something like height, genes aren't going to be the kind of things that we can actually, operate with. I think that's reasonable. But I don't think that we should sort of hope that that's the case and then ignore the ethics if it turns out that it's not the case. So, as I mentioned before, what I'm kind of interested in is, what's the possibility? What would it look like for medical decisions to be made in light of genetic information about the child? There's 2 parts to that. One would be, is it available? Is it likely that parents and physicians would actually get access to the whole genomes of newborns and children? And the second question is that the sort of thing that parents and people would even be interested in getting? Because if the answer is no to either of those questions, then there's no reason for me to proceed, right? And so what I'm going to try and do in this section is make the case for why I think the answer is yes to both of those questions. I don't think that people are going to get access to children's CD14 and DRD4 genetic information because parents are going to walk into the pediatrician's office and say, I want to do a genetic test for CD14. I'm interested in making a decision about daycare. Or, I want to do a genetic test for DRD4 because we're deciding what kind of parents we're going to be. I think this stuff is actually, it's going to be a sort of unintended byproduct of whole genome sequencing. So there's a huge push now for whole genome sequencing. There's lots of kind of industrial and private money behind it. This is just a sample of the companies that are out there that are racing to provide a whole genome sequence of individuals for cheaper and cheaper and for faster and faster. The prize that everybody's shooting for is the $1,000 genome. You see this term kind of thrown around. What they want is to be able for $1,000 to sequence an entire genome in a matter of hours. That's the kind of target that they're looking for. Now you might say, yeah, but these are just kind of private endeavors. They're trying to kind of make money, and what that means is selling people on the hype, and so that's all we're really getting here. Just a year and a half ago, the NIH invested $25 million to look at whole genome sequencing of newborns. And they distributed that money to 4 different centers. Now, a number of those centers, what they're doing is doing whole genome sequencing of newborns that end up in the NICU for reasons that people can't figure out what's wrong with them. And so the thought is, maybe if we can kind of do a whole genome sequence, we can find these rare variants that are accounting for diseases that we just don't have a lot of information about. But one of the centers that was set up by Robert Green and Alan Berg there, this is a joint effort between Brigham and Women's Hospital and Harvard Medical School. They call it the Baby-Seq project. They're actually doing whole genome sequencing of healthy babies. And what they're interested in part, is how is having the whole genome sequence of healthy babies going to affect the kind of medical care that they get as they move through life. Okay? So it's not just private research, it's not just investors that are trying to kind of bank on the promise of whole genome sequencing. The NIH, I think this is kind of note, has put money in it, and people are establishing centers to do things like sequence healthy babies. So again, what's the likelihood that it's actually this sort of information is going to become available? I think the way it's going to become available is just by a whole genome sequence happening of a child, not because they're interested in any particular gene, but because the direction that these people are pushing for is that just becomes a kind of standard part of medical care when children are born now. And then that information gets, this is a debate, does it go on the medical chart, do the parents keep it, what's going to happen with it? But basically it's just available, and then people can sort of, inquire the genome when they have a particular question that they're interested in asking. Second question though, would parents even want this information? This was a study that was published last year by Aaron Goldenberg. He's actually affiliated with the Center for Excellence in ELSI Research at Case Western University. So this is a kind of research that's being done by one of the other seers. And what they did was asked prospective parents, would you be interested in getting the whole genome sequence of a hypothetical newborn? Okay? And they presented it in two scenarios. One of the groups, the parents were asked, would you be interested in getting this information about your hypothetical newborn as a part of a kind of pre-existing newborn screening program that already exists? And then the other scenario, they said, what if it was in the pediatrician's office and the pediatrician just said, would you be interested in getting a whole genome sequence of your child there? And I was really shocked by these results. In both conditions, 70+% of the respondents expressed some interest in getting the whole genome sequence of of a hypothetical newborn. That was shocking to me. I thought, maybe 10, 15%. But to get that really big number saying, yeah, why not, right? Now it's worth saying they offered it for free. I'm sure if you attached a dollar amount, that number would go down very, very quickly. But then, what we would say is, it looks like maybe 70 or so % is sort of a ceiling that would then drop, as the dollar amount increases. And just the fact that there's 70% that are kind of interested with no price it is interesting. I mentioned Green and Berg on the previous slide at the bottom there. They actually, just to kind of reinforce the result on the next slide, they asked something similar of people who are interested in their study. How interested would you be in getting the genome sequenced of your child? And they also found, if you kind of go to that Baby-Seq website, they also found that something like 70 or more % expressed interest in getting the sequence of their child. So it's just sort of a bit of independent evidence that suggests this number isn't just some sort of rare fluke. People are interested in it. So, to go back to the lesson of part 2, what is the likelihood that parents would have access to, the CD14 gene information about their child, or the DRD4 information about their child? I don't think it's going to be a product of asking for a genetic test for those genes. If this is going to happen, what I'm imagining the way it would happen is parents just get a whole genome sequence of their child. It's now available, and at different times they talk to their pediatricians about issues that they're experiencing, medical conditions they're thinking about, worried about, and the pediatrician, they sort of can decide whether or not there's information in the genome that they want to access. And the fact that people are suggesting that they're interested in this at some level by a very high margin suggests it's not outside the realm of possibility that people are going to fork over $1,000, get their kid's genome, and then try to make use of it. I can say, having just come out of the world of having a new baby, $1,000 price tag you can find for everything in a nursery. Right? A crib, a stroller. So, $1,000, if you're somebody who's now entering this world, isn't a large number. You're just kind of used to forking over $1,000 for everything that kind of, that you have to purchase. And so, if you're buying all these $1,000 items for your child, and someone's saying, hey, do you want another $1,000, and you find out the genome of your child, I think you're actually, you're likely to find people that are sort of kind of intrigued by this idea. Time to do this? Yeah, okay. So I can move through this pretty quickly. So what I thought I'd do, I'm kind of imagining this scenario. What might it look like for this to actually play out? And there's some text on these next few slides. I hate reading text, but I'm going to do it just in this particular case because I think it helps to sort of get us all on the same page in terms of this is how I'm imagining, right, this could play out. And then you can either say, that sounds crazy to me, or no, that's not how it works in the pediatrician's office, or that's not how it works in my pediatrician's office, or nobody would do that, right? This is kind of where my mind's at. So a young couple has just welcomed a second child in their family. They already have their older son, Vince, to whom they're now adding Jeff. That's the newborn. At Jeff's first visit to the pediatrician, this usually happens a couple weeks after the child's born, or a week after the child's born. The physician asks the parents a lot of questions. One of the questions is, do you want to pay $1,000 in order to sequence Jeff's entire genome? Parents ask, what would this genetic information provide? And the pediatrician says that the whole genome sequence can influence Jeff's care in several ways. It might turn up rare genetic diseases with no medical treatments. Learning of that genetic information quickly allows for immediately responding with the medical treatments. It might also identify cases of gene-environment interaction, where decisions that you'll be making anyway about Jeff's environment can shape the influence of genes on traits ranging from allergies to defined behavior. The parents themselves both suffer from hay fever and eczema, and so does the 3-year-old Vince. So the thought that something could be done to prevent the development of these conditions in Jeff is tempting. What are these decisions, though, make anyway, the parents ask, that could shape the influence of genes on allergies? Dogs in daycare, the pediatrician responds. Depending on which variant of the CD14 gene Jeff carries, being raised in a home with a dog could either significantly reduce his risk of developing eczema or have no effect at all. The same goes for going to daycare and certain allergies. The parents own a cat. I forgot to mention this in that previous study. They did not find the same interaction result for cats and CD14. I have a cat and 2 dogs, so I'm in both camps. I like them both. But these cat lovers are now in a pickle because their cat doesn't do the trick. But the pediatrician explains that cats don't seem to have the same effect. The parents had never owned a dog and had no plan to add one to the family. Turning to daycare, the parents had not yet made a decision about it, waiting to see what it would cost to send the 2. But the prospect of being able to actively shape Jeff's risk of developing allergies by making decisions about pet or child care is attractive. They spend several $100s each year on treatment for their own and Vince's allergies. So the thought that $1,000 now could prevent the development of such allergies in Jeff sounds like a good bet. They proceed with the whole genome sequencing, learn of the child's CD14 status, and basically in light of the information that suggests that getting a dog will reduce his risk of eczema, sending him to daycare will reduce his risk of developing the various allergies. So jump a year ahead. At the 1-year checkup, the pediatrician asks about how Jeff's doing, especially with regards to the family history of allergies. While not allergy-free, the parents report that Jeff is much better off than his older brother or his parents. He doesn't have eczema like his brother, but he does suffer from some of the same hay fever as the rest of the family. The lack of eczema they attribute to Dander, their 2-year-old dog, who they added soon after learning of Jeff's likelihood to benefit from dog exposure. Vince, the older son, now takes an additional allergy medication to prevent his allergy to dander. Still, it seems to have done the trick for Jeff. But Jeff's hay fever, the parents worry, may be the result of the decision not to send him to daycare. For financial reasons, it makes more sense to have one parent stay at home with the kids rather than send them to costly daycare. Might take care of prevented Jeff's hay fever, they ask. It's hard to say, the pediatrician replies. These things are probabilistic in nature, not deterministic, so Jeff could very well have gone to daycare and still got hay fever. The parents nod but seem unconvinced. Last slide here. 1 year later, at the 2-year checkup, the conversation between pediatrician and parents shifts from medical issues to behavioral ones. They complain that Jeff is becoming increasingly difficult to parent. Temper tantrums are common, as is the habit of meeting parental demands with aggressive opposition. They've been trying to crack down on this by increasing the severity of the punishment. That works with Vince. But his disciplinary strategy only seems to escalate the defiance in Jeff. The pediatrician suggests that they refer back to his whole genome sequence. Let's see what DRD4 gene he has. DRD4, he notes, has been implicated in a gene-environment interaction with parenting style. If Jeff has the long version, then an empathy-oriented approach to discipline would likely be more successful than the punishment-oriented approach. that they used on this. The parents considered the apparent effectiveness with which dander prevented Jeff's eczema. So incorporating another interaction in their parenting decision makes sense. They asked the learner the status. He has the long variant. The parents, worried that they may have been mistreating Jeff in light of his genetic status, promised to switch over to an empathy-oriented approach to disciplining their son. Okay, so that's the kind of, again, I apologize for the test and the reading. That's kind of the scenario I'm kind of imagining here. So here's what I want to kind of start by saying. Keep in mind that the idea of a genetic guide to treating children is not a crazy idea, right? When we get information about things like PKU or FAP, that's a version of familial colorectal cancer, what you're using there is genetic information about a child to decide, whether or not to put a child on a special diet. If you have PKU, put them on a phenylalanine-free diet. Then we prevent the development of the cognitive delays associated with PKU. It turns out that a child has a particular gene associated with FAP. They basically monitor that child for evidence of polyps in the colon. When they first see an early sign of it, they'll do a colectomy, take the colon out, and then that child is at much lower risk of dying of early onset colorectal cancer. So that's not new. Right? What makes these sort of studies new, and what I think makes them sort of interesting, is the environmental condition now isn't something like a very invasive surgery, right? Taking the colon out, or something like a very, very specialized diet, phenylalanine-free diet. It's decisions that parents sort of make all the time, right? So somewhere in New York, Manhattan right now, right, parents are having a conversation about daycare, and they're sort of saying, well, what's it going to cost? Do we want to send them here or there? Do you want to stop working? Do I want to stop working? Right? It's a complex conversation that are including a variety of different things. That's happening already, regardless of genetic information. Same thing with dogs. Somewhere, or the DRD4. Somewhere a kid's having a temper tantrum right now, and parents are sort of kind of evaluating, how are we going to respond to this one, right? This happened yesterday too. What are we going to do with the next temper tantrum? This stuff happens all the time. What I think makes these sort of studies interesting, and a kind of, a different way of thinking about bioethical issues that come out of the gene-environment interaction research is, it opens the door to thinking about what counts as a treatment. And by changing, sort of including things that people are making decisions about all the time and implicating them in gene-environment interactions, they're able to think about making these decisions as if they're a treatment for the condition that they're interested in preventing. Okay? So that shift, right, sort of on asking, what would it look like if this happened? Oftentimes, at this point, someone will either say, and this would be great, and let me tell you about why a genetic guide to parenting is kind of something that I want you to invest your money in, right? Or a typical bioethics move is going to say, and let me tell you why this is going to be awful, right? I mean, like this would be really, really bad, and so this is why we have to prevent this from happening. I think if this happened, it would have sort of both advantages and disadvantages. And so what I'm going to try to do in the kind of last few minutes here is just survey 3 different issues that I could imagine being affected by this taking place, and kind of looking at what would the advantages or disadvantages be with parents actually trying to kind of make decisions in light of this. So one domain where I can imagine being affected is parental decision making. On the one hand, I think it would be very empowering for parents were it to be the case that they could affect their child's health based on doing things like making a decision about a dog or parenting this way rather than that way. If a child has something like a family history of colorectal cancer and they're screening for a gene associated with FAP, that is going to be a very medical experience. The testing is going to be done in a hospital. It's going to be done by physician, nurses, and hospital techs. The surgery is going to be done in a hospital. There's going to be a recovery period. Right? I mean, it's everything that happens with that experience, everything that's done with that experience is going to happen in the hospital. If parents learn that their child was at risk of various allergies, and they were told, yeah, but if you go to the local animal shelter and get a dog, that will not eliminate the kid's risk of having allergies, but it would reduce them, right? That seems to me that it would be a sort of empowering experience. It's like, wow, we don't have to kind of, go to the hospital to do something about this. Something as simple as adding a dog to the home that we can do can have an impact on the child. And I think that strikes me as something that would be good. To, the extent that parents can feel empowered by being able to do something about their child's health, that would be a good thing. On the flip side, it would medicalize these decisions. And I think that's a real concern here, right? So our parents in the previous vignette, they didn't add a dog to the home because they were dog lovers, right? They didn't add the dog to the home because they wanted to treat their kid about companionship and loving and responsibility. They basically purchased a dander dispenser, right? And said, okay, now we've got the dog in our home. And not just as a dog lover, but as somebody who's worried about sort of like the medicalization of the decisions that people make, that's a real concern for me. Similarly, when we engage in parenting styles, when we're making a decision about how to respond to kids' behaviors, what you're trying to do is shape that child into what you think they should responsibly turn into, and help them out and treat them. This behavior is okay, and this behavior is not okay. But deciding on an empathy-oriented approach to parenting because the kid has a long version of the gene strikes me as a kind of really weird way to go about doing that, right? So now when the child has a temper tantrum, you're not trying to engage in empathy, you're trying to treat the long version of their gene. There's a lot of research that's been done on this sort of genetic essentialism and genetic essentializing that takes place when genetic explanations are implicated in any kind of behavior, any kind of condition. And the worry here is that kind of implicating a gene in the behavior will just sort of swamp the way people think about how they're relying on that information and how they're making decisions in light of it. And I think that's a real concern. Parental responsibility. The good side of it is, this follows up the previous slide. If they added a dog to the home, kid doesn't get eczema, they can sort of own that and say, hey, we did that. That's great, right? You can kind of take the parental responsibility. The flip side, right, they didn't send the child to daycare. The child develops hay fever. They're now worried that they were sort of somehow implicated in the development of that condition. Now, there's lots of research that says when children have genetic tests and they have some kind of rare genetic condition, like PKU, the parents will feel guilty, but then genetic counselors and pediatricians can say things like, look, this isn't your responsibility, it's a rare roll of the genetic dice, right? There's no reason you should feel responsible here, you couldn't have done anything about that. But obviously with these cases of gene-environment interaction, where the parents actually could affect that, if they have access to that information, and decide not to do it for whatever reason, right? It turns out it was too expensive. It turns out that I want to raise my kids in my own home. There's a sense in which parents could have done otherwise but didn't, and you can't just tell them, well, you couldn't have done anything about it. So the other side of this one is you can take responsibility when it works, but you also have to bear it when it doesn't work. And then the last kind of domain that I see would be affected by this, along with genetic essentialism, is genetic determinism, which sort of just runs rampant in society. People think genes cause things like IQ and obesity and height. What I like about these cases of gene-environment interaction is they just sort of pull the rug out of genetic determinism, right? In all those cases that I'm looking at here, right, if I said, which gene causes eczema or which gene causes externalizing behavior, you can't answer that question because it really depends on which environment you're in. And I think that's a valuable lesson. I think it would be, for most people, the only time they ever hear about genetics is either sort of freshman bio, when you learn that genes make peas green versus yellow, or genes make plants short versus tall. And then the next time, I experienced this recently with a genetic counselor, you hear about genes doing things like creating traits for your babies that you should be really, really concerned about. So I think most people have limited information with genetics, and the genetic information they encounter is very deterministic. And so to the extent that parents would be exposed to things like gene-environment interaction, have to think about gene-environment interaction, I think that would be sort of a service. It would be helpful for people to realize that the world is much more complex. The flip side of that, though, is genetic determinism could be replaced with a sort of gene-environment determinism. Right, so what I have in mind here is think about our parents at that very last slide, right? They learned that Jeff has the long version of DRD4, and they realize that up until this point, they've been engaging in low sensitivity parenting, and they're told that in light of the genetic information, they should be engaged in high sensitivity, empathy-oriented parenting, right? They might think, my God, right? I mean, he's both, genetically predisposed, and we've been sort of like hitting him over the head with a hammer, that's not how we're supposed to be treating their genome. it's this sort of like double dose of risk, right? That the two things that are both contributing, and it would almost be a heightened sense of determinism, even if it's not purely genetic, right? I mean, as somebody who's interested in the science and interested in misunderstanding about the science, what concerns me is people think these things deterministic and cause things that are immutable, and they're not. Just replacing genetic determinism with gene-environment determinism doesn't make that any better. The concern here is it might actually kind of, compound it. So just to wrap up, we have not sequenced Olivia's genome. No plan to do so. So, I don't think this is the sort of thing that's, on the immediate horizon. But I think, in light of the push for this whole genome sequencing and the apparent interest in it, it does strike me that when people are reflecting on the ethical issues that are associated with whole genome sequencing in children, a lot of times what they're doing is talking about things like, well, what if we find out that they have the gene that's associated with Alzheimer's disease? Or what if we have the gene associated with increased risk of breast cancer? And so they're thinking about, what if we find out genetic information about this child that's going to affect an adult onset condition, and now we've kind of got that information and the child didn't have a chance to make a decision themselves, right? I think that's, that is a genuine concern. But what I'm trying to kind of do here in moving bioethics and these ELSI issues outside the shadow of the Caspi-Moffitt study is to say that's not the only way it can be used, right? It's actually also possible that decisions can be made about that child in light of that genetic information, and that's something that we should also be concerned about. Thank you.
So I have about 10 minutes for your questions and comments, and I'll give you a little more light to Yeah, please.
Hi, so I had two things that occurred to me, or that have occurred to me.
Yeah.
About this. One of them is that some of the stuff is a lot like what we've learned about what women should and shouldn't do during pregnancy. Especially in terms of the burdens that you discussed at the end.
Yeah.
But, you know more, and that's really empowering. So you can not smoke, and but it also has a real burdensome side of it.
Yeah.
And it strikes me that similarly, this way of thinking might be disproportionately the burden on women. So, that same dynamic, I mean, not as much, but a similar dynamic plays out there. So if you find out a lot of those things would fall to women,
right?
Already, even just
like childcare, like
dog
feeding the dog, yeah.
No, really,
yeah.
Or that's the parenting.
That's a really interesting point.
So I think that's an interesting dynamic in this too, like a troubling dynamic to me anyway. And I do think that the empowering can be overblown and the burdensome can be under-recognized. It's like, oh, they're both, but like, I really love them, but they're not something like that.
Yeah, and the thought is the burdens and benefits might be distributed disproportionately.
But by sex and class,
right, good.
As well, right? Sex and class, massively, I would think. And then the other thing that kind of occurs to me is, especially, I love this example of the parenting style.
Yeah.
Is that I sometimes worry that it also, there are lots of reasons why a more empathetic parenting style could be recommended to parents.
Yeah.
And the risk is that we start seeing this as the reason. So the reason that I recognize you, my small child, as a human being who has feelings and I acknowledge them, blah, 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 do all these things that actually there are so many good reasons to do.
Yeah.
That just becomes about genetics, and then we lose something in understanding who we are and why we are doing what we're doing. We're doing the right things, but we've lost the richness of the reasoning behind it, and I sort of worry about that too.
Another sort of the swamping that occurs.
Yeah.
Just a second. So I mean, and the other reason, what concerns me about that scenario isn't just that. The kind of rationale would be swamped by genetics, but also you might take other things that are perhaps more important, you might not take those into consideration. So I'm imagining something like, we were focusing all on Jeff on that scenario. Think about Vince, right? Vince has been severely punished for his misbehavior up until this point. Now Jeff comes along, and he does the exact same thing, and there's Jeff, we talked about this, let's kind of focus your attention over here. And Vince's thing, I just got spanked for that, right? So, the concern there would be, there's other principles of parenting, like, you know, being fair and teaching your kids about, you know, what's appropriate and inappropriate behavior. And if you thought, well, there's a genetic difference between them, and that's why we're doing it this way with Vince and that's why with Jeff, right? It doesn't just sort of kind of forget the rationale for it, but actually, you know, does a disservice to those other reasons which you would think would be much more important if you're interested in sort of shaping, you know, humans. Yeah, Jeff?
I mean, and building on that and building on what you said about the sort of medicalization of all these decisions, I think there's sort of a direct way in which if the parents go to the doctor, like, good news, you know, doesn't have any of these genes where these things matter. We point out that dogs, just like daycare and sensitive parenting style, these are all things that are generally done for pro-social reasons.
Yeah.
And so by reframing these decisions as medical decisions, I think there's a real sense in which parents might take that as, oh, I don't have to be sensitive to my kids. I don't have to have a dog. I don't have to get daycare. And that's sort of directly problematic if there's a lack of a gene that puts the child at risk.
Absolutely. Yeah, yeah. I mean, the other thing I could imagine transpiring, this is only because having given this talk somewhere else, people suggested, well, if it's the dander that you want, then maybe what's going to happen is there'll just be sort of a market for, you can buy dander, right? So you don't get the dogs. You don't have to worry about the kind of issues associated with dogs. But, like, you know, you go down to the local vet and you're going to get, you know, your bag of dander and you dump it in the furnace air conditioner. I mean, this just sounds gross. This is probably what my house looks like with dogs. But the thought that you would, you know, buy this stuff that we're always trying to get rid of. But it's concealed. I mean, I thought, well, that would be an alternative way to kind of introduce this into the environment without engaging with these other problematic issues. I just think that's kind of silly. Yeah, Maya, and then right next door.
Thanks. Obviously, a question many parents question themselves: how do we parent with genetic information, and would it have any impact? But I think there's another thing that's kind of missing, because it's not enough to test the child. We'll have to test the parents as well to figure out how they respond and interact with programs to teach them how to parent their child with a specific genetic condition.
Yeah.
So we're kind of holding a whole, literally creating genomic families in a completely different way. And it would bring so many additional what?
Anxiety.
Well, anxieties that will exist anyway. But in terms of how would the state be involved in that? Who is going to provide those programs to parents? Why? Where do you exactly balance it? How do you bring in that not everyone in New York can afford daycare for their 0 months child?
Mm-hmm.
There are a lot of other issues, and so I think there's kind of, it's not just the child who's being tested, it's not only the child who will be worked at, but it actually requires a different.
That's great. Yeah, so you're right. I didn't get into any of that stuff, and it wasn't because I don't think it's interesting or important, but, you know, I just want to sort of carve out this area and think about how would this alter this space.
But it's a question that I've had.
Oh, sure. So the concern was, you know, let's think about the fact that, you know, if there's going to be a market for whole genome sequencing, only certain people are going to be able to have access to it and not others. Think about the fact that you don't just kind of tell parents to parent this way or that way. The thought would be, maybe we actually have to kind of find out what sort of, are they genetically predisposed to parenting in different ways, and so maybe we want to sequence them too and find out, you know, whether or not there's a kind of interaction effect between genes in them and parenting styles. And so, yeah, I agree. There's kind of this, there are sort of ripples that go out from this and affect larger and larger levels. I just focused on that one little niche. Yeah, please. And I'll start repeating from now on. Yeah.
I was just thinking about the premise that you sort of start with and the examples that you provided around dogs, daycare, and discipline, and the ways in which those, even as environmental sort of triggers or reactions in relationship to genes, are very much formulated as still quite causal, right? Like, if you have the genetic predisposition, then that action will have this result.
Yeah.
And you even showed in your sort of vignette that it had some of those results, but not all of them, right? And so it just brought up for me, first of all, the challenges of determinism, even when you introduce environments, right? The environments are not controlled, and the genes themselves are not necessarily directly controlled.
Yeah.
And then at the same time, you have this example of the whole genome being sequenced of a child, and that being referenced back by, say, a pediatrician, which in this scenario has a lot more information than I think most pediatricians have, right, and can interpret the data
genome
Absolutely.
much more astutely. But you also have a test that's going to change dramatically over a child's lifetime, right? So the data that's gathered by a whole genome sequence of a child, today, is going to be a very different sequence than what might be gathered for a child that's born 10 years from now, right? And if you're always referencing back, there's going to be this market push as well as sort of individual push, I think, to continually have that updated and evaluated with the latest and greatest technologies, while at the same time, creating a very challenging environment for people to keep pace with that, and to provide any resemblance of advice in these realms, which are already so muddy. So I think it raises